Translating verbal expressions between math and English. I have a claim, which is that algebra is a different language than English. And the algebra one course, part of it is learning algebra, and part of it is learning how to translate between your native language and algebra. Since I'm speaking English, I imagine that we'll be talking about translating between algebra and English. Um, the idea is if you take an algebraic expression, an algebraic equation, something written in algebra and hand it to someone who does not speak English, they will still be able to interpret it equally as well if they have learned algebra. So, a simple example is you see basketball, 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 basketball. Well, we describe this as 5 basketballs. If you say that in English, you'd say the word 5, F-I-V-E. But the way you write that algebraically is you'd write the numeral 5, and you could say, okay, that numeral 5 doesn't just describe having 5 basketballs, it describes having 5 stars here, or 5 senses 1, 2, 3, 4, 5. Or you could go even further and say, okay, there are 5 pictures on this screen, and there's an entirety of 5 objects altogether. You could even say that, okay, there are 25 objects here, 5 plus 5 plus 5 plus 5 plus 5, or 5 times 5. Understanding why we would do multiplication there is part of understanding what those algebraic expressions mean in English. Learning keywords, switch words, and shortcuts can help, but nothing can replace vocabulary and grammar. It is very easy to jump to conclusions, to see things that are not trying to skip over the thinking or skip over the language, but you have to know the language, specifically the vocabulary and grammar. If you're struggling with vocabulary or struggling with grammar, the math will be difficult for you. So, addition. What we know, I'm assuming that you know how to add. The question is, when would you add? Well, addition represents combining separate groups or actions. So here we have 23 tokens. We have 12 tokens. We combine those together. So now we have 35 tokens. If we have a length, or a piece of wood that's 2.9 square feet, and we add another 16.3 square feet to it, it becomes a total of 19.2 square feet. It also counts when we're adding negative things. So if they're going in opposite directions, you say you're starting somewhere, you're going south 5 miles, and then you go north 15 miles after that. Well, compare from where you started to where you ended was up 10 miles. So we combined those two movements and ended up with a movement that was a total of positive 10. Negative 5 plus 15 is positive 10. These are words that frequently signal addition. You can read them yourself. Just be careful. Not always. There are times that you'll see these words and it will not be addition. Subtraction represents removing, separating, missing, or undoing separate groups or actions. It's the opposite of addition. So if we take that same 23 and remove 12 tiles from it, well, what we're doing is we're taking 2 1s and a 10 and subtracting that out, and we're left with 11 tiles. If we cut off, if we have 2.9 square feet and we subtract 16.3 square feet, well, that's saying that we still need more in order to get back to where we started. If we're trying to figure out how much more do we need, well, we're missing 13.4 square feet. So that's why I have a dotted line. It's important that you recognize this is negative because we're subtracting the larger number from the smaller number. And if we're going south 5 miles, and then we go the opposite of going north 5 miles, well, the opposite of going north 5 miles would be going south another 5 miles, 15 miles. So in total, we need to go south 20 miles. This is how subtraction works. This is the opposite of north. The opposite of north would be south 5 miles. or south 15 miles. These are words that frequently signal subtraction, but that doesn't mean that it's always subtraction. Multiplication is the idea that, okay, we have a group of 23, and we have 12 groups. That's a total of 276 total. If we have a width and a height, you can multiply the width and the height together to find out how much space is inside the object, and that's repeatedly adding. Okay, we have 2.9 plus 2.9 plus 2.9, 16.3 times. Here, if we say, okay, I'm going south 5 miles an hour, and I'm doing that 15 times, 15 hours. So it's not that I'm adding those two things together. It's that, okay, I'm going 5 miles, I'm going 5 miles, then another 5 miles, then another 5 miles, 15 times, until I eventually get all the way down to south 75 miles. So it's repeatedly adding this south 15 miles per hour that ends up being south 75 miles. Words that frequently signal multiplication, these, be careful. The word of definitely means multiplication sometimes, but it's definitely also means just its normal English meaning sometimes. Per is definitely something that can mean multiplication, but it also is on the division side. Twice is 2 times something. Doubled is also 2 times something. Division. Fractions or division symbols represent separating into equal sized groups. So if you take 24 things and you're splitting them into 12 groups, you need to have, each group needs to have 2 in them in order for the groups to be equal size. Now, if we take 16.3, a length of 16.3, and we're cutting it into pieces of length 2.9, well, there are 5 full pieces, and you're 0.62 or 62 hundredths of the way to getting another piece. If we're going south 5 miles, over the course of 15 hours, that means that we can be going a third of a mile per hour south. So if we go a third of a mile per hour, and then another third of a mile per hour, and then another third of a mile per hour, if we do that for 15 hours, then we'll end up going south 5 miles, and that's through division. Words that frequently signal division: per, every, each. Half is always 1/2. You can describe this as 1/2 times something, which is why you have to be careful about division, or you could say that it's something divided by 2. Parentheses represent grouping components together. So exponents are repeated multiplication. Fractions represent division. Equality, whenever you see a version of to be, that usually will have an equal sign if there are numerical expressions on both sides. And inequalities represent comparison. So this is less than. Be careful. Is less than is that symbol. But if we go back to the subtraction slide had less than signaling subtraction. So 5 less than 7 gets translated into 7 minus 5. Note that 5 less than 7 is 2, not negative 2. If we say 5 is less than 7, it gets translated as 5 is smaller than 7. Those are two very different statements. And it's pretty obvious when you're dealing with numbers, but once you start dealing with variables and other more complicated expressions, you need to know this difference. Some vocabulary. You need to know all this vocabulary. It will come up throughout the year. Constant is an item in a number system whose value and properties can't change from problem to problem. Usually, this is something like 3 is a constant. A variable is an unknown or changing value or its placeholder. The most common thing we use is X. It stands for the thing, translated through a few different languages. Historically, you might have seen this in lower grades as a blank or a shaded in box, saying you don't know what this thing is, find out what this thing is. Well, X is usually what we'll use to represent some unknown thing. A parameter is a variable you pretend is a constant. You have something that we don't know, but you also say that it can't change. That's much easier to explain when you see an example. Operations are things that change numbers from one thing to another. It doesn't have to change. If you add 0, that's technically an operation. So if you add 0 to x, addition is still the operation. But it's not comparing things together, so all these symbols are not operations. An expression is a statement containing only constants, variables, parameters, and operations. So there's not going to be a comparison symbol, no equal sign, or any of the others. So if we look at this one, here we have -2 is a constant, or you could argue that 2 is the constant. Negative or subtraction is an operation. X is a variable. And the whole thing is an expression. One word I did not use is that 5 is called a coefficient. In this one, we have 4 variables. Y, M, X, and B are all variables. But if you've seen y equals mx plus b before, you know that usually we know what m and b are in y equals mx plus b. Those are called parameters because usually I will give you something like y equals 3x plus 2. When I say y equals 3x plus 2, we say, okay, m and b, we usually know what m and b are. Those are our parameters. They're still variables, but a better term to describe them is parameters. This is not an expression. This is an equation. And the reason it's called an equation is because it has the equal sign. Without an equal sign, it's called an expression. Again, you cannot just memorize these words. It's a good start, but nothing can replace knowing the vocabulary and the grammar. You are allowed to make your own variables. You can use variables to represent unknown or changing information. So use these 3 rules whenever you're making your own variables. Name each variable. If you're going to say t, make sure that you know that t is representing whatever it's representing, in this case time. Don't use different names, use different names for different things. So please don't use x for 2 different things in the same problem. What you should do is change this to be, okay, now this is y is money. And case matters. If you use 2 different versions of the same letter, those are considered different by mathematicians.